Let's try this again. Third time hopefully is the charm. If it chipmunks my voice this time, you guys are just stuck with it. There are two different ways that you could approach 1 through 3. There are two formulas that can be used to find an interior and an exterior angle in a regular polygon. To find an interior angle, you can use the formula 180 times n minus 2 divided by n, where n represents the number of sides. In this case, number 1, n would be 4 in a quadrilateral. An exterior angle, you can use 360 divided by n, again where n represents the number of sides. Because in any type of polygon, no matter how I draw it, when I look at an exterior angle and an interior angle, and I put them together, they always form a linear pair. In other words, they're always going to add up to 180. It is easier to find the exterior angle first and take the exterior angle and subtract it from 180 to find the interior angle. So I'm going to do two of them this way, where I find the exterior angle, and I'll do number 2, where I use both formulas, so you can see the difference and you can decide which way you'd like better. So I'm going to take 360 divided by 4. That gives me 90 degrees for an exterior angle. To find my interior angle, I'm going to take 180 minus 90. In this case, this one is also 90 degrees for my interior angle. Using the other formula for an octagon, I'm going to use the interior angle, 180. Since there are 8 sides in an octagon, n represents 8, so I'm going to take 8 minus 2 divided by 8. The interior angle will be 135 degrees. The exterior angle, I'm going to take 360 and divide it by that n, which is 8, and I'm going to find that this is 45 degrees. And we should notice that these two add up to equal 180. And again, just because I like using the exterior angle formula better, I'm going to take 360 and divide it by 180. I'm sorry, by 18, because it's an 18agon. It will give me the measurement of an exterior angle. And this is going to be 20 degrees. To find the interior angle then, I'm going to take 180 minus 20, which is 160 degrees for my interior angle. Numbers 4 through 9, all done the same way. This is the sum of the interior angles of a polygon. The formula for the sum of an interior angles is S equals 180 times n minus 2. This is all driven from this formula. Once you've done one, you can see we can get rid of the formula. You can see how to do it. I'm going to replace this n with 1,440, and it's equal to 180 times n minus 2. Because S represents the sum, I replace the sum, and I'm using it to find n, which is the number of sides. To get n by itself, I'm going to divide by 180. I'm going to leave this way just so that you can see what we're doing. This is equal to n minus 2. And the opposite of subtracting 2 would be to add 2 to both sides. So what I have is this, 1440 divided by 180 plus 2 is going to be equal to my n. The reason I left it this way is because then you can see that that's what we're going to do for each one of these. When I do 1440 divided by 180, that'll give me 8. 8 plus 2 is 10. So this will have 10 sides. I can take each one of these and I can see I can divide it by 180 and I can add 2. That means this will have 12 sides. Divide by 180, add 2. This will have 16 sides. Divide by 180, add 2. 24 sides for number 7. Divide by 180, add 2. Number 8 will have 32 sides. Number 9, divide by 180, add 2, would actually have 90 sides. Would be a 90-agon. Numbers 9 through 14 deal with a parallelogram, and you have to know the properties of a parallelogram. Opposite angles of a parallelogram are equal. So I do know that 5y is equal to 110. I also know that consecutive angles add up to equal 180 degrees. So I would have 3x plus 7 plus the 110 is equal to 180 degrees. Solving, I'd divide by 5. X is equal to 21. Combining like terms, 3x plus 117 is equal to 180. Subtracting the 117 from both sides would give me 3x is equal to 63. And so when I divide by 3, I'm going to get x is equal to 21. I was looking at the wrong part. Obviously, this is y equals 22. 110 divided by 5 gave me my y value. It's what you get for being in a rush because it's chipmunked 3 times on me. Number 10, diagonals bisect each other. So 19 is equal to 3x minus 2. 2y plus 6 is equal to 3y minus 2. And again, just simply solving these algebraically, adding 2 to both sides, I have 21 equals 3x. Dividing by 3, x is 7. Putting my y's together, I have 6 equals y minus 2. Adding 2 to both sides, I get y equals 8. Opposite sides of a parallelogram are congruent. So y equals 3y minus 8. The other equation would look like this. 4x plus 6 equals 2y. I definitely want to solve the first equation first because it has one variable in it, and then I can come over here and replace that variable with its value. Subtracting 3y, I have a negative 2y equals a negative 8. So when I divide by a negative 2, y is equal to 4. I come over here and I replace this y with 4, which gives me 4x plus 6. 2 times 4 is 8. And again, I just simply solve this algebraically. 4x is equal to 2. And when I divide by 4, I get x is equal to 1/2, or you might have 0.5. So x is 0.5 and y is 4. In a parallelogram, opposite sides are congruent, so 2x would be equal to x plus 3. And because the sides are parallel, alternate interior angles would be congruent, so 4y minus 1 would be equal to 3y plus 4. Again, solving algebraically, this is going to give me x is equal to 3. Putting my y's together, I now have y minus 1 equals 4, and adding the 1 to both sides, y is equal to 5. 10 and 13 are nearly identical. I do know that the diagonals bisect each other, so I would know that 5x is equal to 26, and that y minus 1 is equal to 3y minus 10. If I divide by 5, I could leave it as an improper fraction so long as it's simplified, or I could change that to a decimal, and when I take 26 and divide it by 5, I get 5.2. Putting my y's together, I now have a negative 1 equals 2y minus 10. Adding 10 to both sides, I have 9 equals 2y. And again, when I divide by 2, I could leave this as 9 over 2, an improper fraction, or I could change it into a decimal, 4.5. Number 14 is nearly the same as number 12. It's just missing one part. But I do know that alternate interior angles would have to be equal. So 2x would be equal to 3x minus 3. Subtracting 3x from both sides, negative x would be equal to a negative 3, which means x is going to be a positive 3. Number 15 through 20 should be one of those problems that everybody gets right. If you have 3 or more parallel lines cut by a transversal, and it cuts it in a way that it cuts it into equal parts, then every transversal that goes through those parallel lines will also be cut into equal parts. Which means from M to N is 5, from O to P is also 5. From Y to O is 7.2, and from O to Z is also 7.2. Then I just look at what they're talking about. From M to O is 2 of these 5's put together. I won't write them out after this. 5 plus 5, obviously 10. 15, from P all the way to M is 5 plus 5 plus 5, a total of 15. From M to N is just one of those pieces, it is 5. From Y to Z, 7.2 plus 7.2, 14.4. From Z all the way to X is 3 of the 7.2's put together. 7.2 plus 7.2 plus 7.2, 21.6. And from O to Z is just one of those pieces, 7.2. Number 21 and 22 work off of the same concept. I know that this is just a quadrilateral. They didn't tell me it was a parallelogram, a rectangle, a rhombus, a square, a kite, or a trapezoid. It may look like it's one or the other.
Martina Taylor, please call extension 1570. Once again, Martina Taylor, please call extension 1570.
But I cannot determine that. So I'm going to let the sum of the interior angles be 180 times n minus 2. And in this case, n represents 4 for both of these problems. By now, we know that the sum of the interior angles of a quadrilateral is 360. We know it about as well as we do a triangle. If I take a look, these two angles should add up to 180. So I could have this, y plus 2x plus 10 equals 180. But if I did this first, I'd have both an x and a y. If I go around the inside, all of these should add up to 360. So if I take x plus 2x plus 10 plus 3x minus 14 plus 4x plus 24, it should be equal to 360 degrees. If I combine my like terms, it is going to give me 10x plus 20 equals 360. Subtracting the 20 from both sides, I get 10x is equal to 340. So when I divide by 10, x is equal to 34. Now, I could go back here and plug this in. 2 times 34 is 68, plus 10 is 78. And I could use that to find y, or I could have written this equation out and I could have done the same thing. Y plus 2 times 34 plus the 10, you can see that that's going to be my 78. So I'm going to subtract that from 180 to get what y is, which is 102 degrees. Number 22 is easier. It still uses the same concept. Inside has got to add up to 360, but I do have two variables on the inside this time. So I'm going to find the value of x. 114 and x form a linear pair. So to find x, I'm going to take 180 minus 114. And I find out that x is 66 degrees. And if I put that back in, then I can add all of my angles together. I've used 66, I've used 110, and I've used 93. So I've used a total of 269 degrees. And I know that whatever y is has got to be 360 minus this 269, because there's 360 degrees in here. So y is going to be 91. So x is 66, y is 91. Number 23 through 25, use the properties of a kite. Remember that in a kite, the diagonal that goes between the two congruent pieces does bisect that angle. So if this was 42, over here would be 42. If this was 3x plus 5, this is also 3x plus 5. Opposite angles, the angle that's between the two non-congruent sides would be equal. So I would have one equation that might look like this. 7x plus 3 could be equal to 8y, but I notice that I have two variables. A lot of times things in kites and rhombuses boil down to looking at a triangle. If I look at this triangle, I know there's 180 degrees in it. I've used 42, 7x plus 3, and 3x plus 5. And that should be equal to 180 degrees. I can use this to find x, and then I can come over to this equation and replace my x. Combining my like terms, in this particular problem, I would have 10x plus 50 is equal to 180. Subtracting 50 from both sides, 10x is equal to 130, which means x is equal to 13. Again, if I plug that back in, I'd have 7 times 13 plus 3 is going to be equal to my 8y. So when I do this, I get 94 equals 8y, and I divide both sides by 8. Y is equal to 11.75. There's certainly nothing wrong with getting a decimal as an answer. Number 24 is a little bit easier. The two angles that are between the two non-congruent sides are equal. So I do know that x is equal to 130 degrees. I also know that there's 360 degrees in any quadrilateral. I've used 130, 130, and 86. So I know whatever y is equal to 360 minus my total here, which is 346. So y is equal to 14. Again, I know that the diagonal that's between the two congruent sides bisects an angle. So if this is 51, this is also 51. If this is 29, down here is 29. So I know this much already. Z equals 29. I do know that diagonals are perpendicular. So I can look at two different triangles to find x and y. Here's the triangle that I'm going to look at for x. It's highlighted in green. And I'm going to highlight the other one in kind of this pinky purple color. And I can use that triangle to find y. So I've had 90 degrees and 51 in the green triangle. I've used 141 degrees of 180. So there is a total of 39 degrees left. So x is 39. Likewise, when I look at where the y is at, I've used 90, I've used 29, I've used 119 degrees of 180. So there is 61 degrees left, and that is my y value. In a trapezoid that's isosceles, base angles are congruent. So this equation would simply be 7x plus 10 equals 5x plus 26. Subtracting 5x from both sides, I have 2x plus 10 equals 26. Subtracting 10, 2x equals 16. Dividing by 2, x equals 8. In this next problem, they gave me the length of AC. I can see it's an isosceles isosceles trapezoid again. They told me AC, one of the diagonals, was 3x plus 5. They told me my other diagonal was 4x minus 30. And in an isosceles trapezoid, I do know that these two values are equal to each other. So 4x minus 30 is equal to 3x plus 5. Solving this algebraically, putting my x's together, I have x minus 30 equals 5. Adding 30 to both sides, I get x equals 35. Number 28, base angles are equal. So 97 here, z is also 97. Consecutive angles in a trapezoid between the two parallel sides would add up to equal 180. If I've used 97, the remaining angle then would have to be 83 degrees. Since base angles are equal, x is 83, but y would also be 83. So x is 83, y is also 83. In problem number 29, the 2x plus 10 is a mid-segment of a trapezoid. It's a mid-segment because it's connecting the two midpoints. I can take 2 times the mid-segment and set it equal to the sum of the two bases, 6x minus 12 plus 18. Distributing gives me 4x plus 20. Combining like terms gives me 6x plus 6. Putting my x's together gives me 20 equals 2x plus 6. Subtracting the 6, 14 equals 2x. And dividing by 2, x is going to be 7. These should be super easy if you know the definitions of a rhombus, rectangle, and a square. This is a square. It has 4 congruent sides and 4 right angles. Number 31 is a rhombus. It only has 4 congruent sides. Number 32, this is a parallelogram. But remember, in a parallelogram, opposite angles are equal. So these both would be 90. And consecutive angles add up to 180, so each of these would be 90 degrees, which makes this particular figure a rectangle. Number 33, I see I have 4 congruent sides again. This is a rhombus. In number 34, I can see I have 4 right angles, but the other sides are not congruent, so this is a rectangle. 35 through 40 all deal with the properties of a rhombus. Remember that diagonals of a rhombus are perpendicular. I just would get in the habit when they put them in there to go ahead and draw that in. It does give you some of the angles right away. Like in number 35, angle 2 is 90 degrees. The diagonals of a rhombus bisect opposite angles. So in number 35, this is 21. This would be 21. This piece would be 21. This would also be 21. Whatever 3 is, 4 would be the same, 1 would be the same, and so would the other angle on the other side of 1. So most of the time this boils down to the fact that you can look at a triangle.
Holy moly, what are you doing here so late?
Yep, still recording something. It can been chipmunking on me.
Were you in the seminar yesterday? Or the,
No.
whatever they call it?
I am going to take my 90 and my 21, add them together. That's 111. I'm going to subtract that from 180 degrees, and it is going to give me 69. Which means angle 1, angle 3, and angle 4 are all 69 degrees. When I come over and look at number 36, I already know that angle 4 is 90 because the diagonals are perpendicular. Whatever angle 2 is, angle 3 is going to be the same. And I need to find the measure of angle 1 as well. Because diagonals bisect opposite angles, if this is 65, over here would be 65. Angle 2 and 3 would also be 65. Then again, I can look at a triangle. I can see I've used 90 and 65. So I've used 155 degrees of the 180 that's in the triangle. Remaining angle then, angle 1, would be 25 degrees. I do know that diagonals bisect opposite angles, so if this is 56, angle 2 and 3 are going to be the same, and in fact they would be 56 degrees. If I look at a triangle then, I do know that these are both 56, so I've used 56 and 56. I've used 112 degrees of 180 degrees. And that is going to leave me a remaining angle of 68, which means angle 4 and angle 1 are both 68 degrees. Angle 2 in number 38 is the one that's 90 degrees. Angle 4 and angle 1 would both be equal because they bisect opposite angles, and it is going to be 72 degrees. And the only, angle 3 is also here in the middle, so it's also 90 degrees. None of them were in the middle here this time, but I do know that the diagonals bisect opposite angles, so 3 and 4 are the same. And in fact, the measure of angle 3, which is equal to the measure of angle 4, would be the same as the 17 that's in that corner. And then I would use the concept of this triangle being 180 degrees. I've used 17 and I've used 90. 90 and 17 is 107 degrees. So the remaining angle in the triangle would be 73 degrees. So angle 3, angle 1 is 73. Angle 2 would be the same. Angle 2 in number 40 is 90 degrees. I do know that the diagonals bisect opposite angles, so the measure of angle 4 is 52. And again, I can go to any triangle then and take a look to see how I'm going to find angle 1 and angle 3. Since angle 4 is 52 degrees, I've used 52 and 90. I've used 142 degrees of my 180. So there is a total of 38 degrees left. So angle 3 and angle 1 are both equal to 38 degrees. Be careful, make sure you read all of this. We got to find the value of the variable and the length of the sides. This is a square, so opposite sides are equal. Y plus 60 would be equal to 3y. Solving would give me 60 equals 2y. Dividing by 2 would be y equals 30. Plug that back in. 3 times 30. The side would be 90. I know that this is a rhombus, so all the sides are equal. 15x minus 6 is equal to 10x plus 24. Again, solving, I'm going to subtract 10x. Gives me 5x minus 6 equals 24. Adding 6, 5x is equal to 30. Dividing by 5, x is equal to 6. Plugging that back in, 10 times 6 is 60, plus 24 is 84. So my side is equal to 84. In a rectangle, opposite sides are equal. So 2x is equal to x plus 7, which means x, when I subtract x from both sides, would be 7. I can already plug that back in and tell you that this side is 7 plus 7. So the side is 14. Likewise, on the other side then, the longer side of this rectangle, I can see that 3y plus 13 would be equal to 8y minus 2. Subtracting 3y from both sides would leave me 5y minus 2 equals 13. Adding 2 gives me 15 equals 5y, which means y is equal to 3. When I plug that back in up here, 3 times 3 is 9, plus 13 tells me that this side is 22 units long. Again, number 44 is a square, so I know all the sides are equal. So I do know that 3x plus 11 is equal to 4x minus 3. If I subtract 3x from both sides, it gives me 11 equals x minus 3. Adding 3 to both sides, x is equal to 14. If I plug that 14 back in, either one of these places, 3 times 14 is 42, plus 11 gives me 53, so all of my sides are 53 in this problem. If you are in Geometry Honors, the two questions that were up on the board, the first one should have proven to be a rectangle. The second one would just be a parallelogram.